Quadratic equations, all right? Your first layer difference is what you've done on the first test. And on the second test, we're going to talk about second layer differences. Y'all saw it coming. Nice. All right. So for linear, first layer differences, linear, that says linear, is y equals x. That's super basic. That's the entire unit 1 test. But now, quadratic is y equals x squared with a power of 2 right there. Okay.
Oh, because it's the second.
Oh, because it's the second layer is exactly the connection I was kind of seeing if y'all were make here, right? The first test is only over x because it's just the first layer difference. The second test is x squared because it's the second layer difference and the 2. And next week, next unit is the third test, and it's x cubed, which is the third layer difference. So we're all building up, okay? So that's important to know. And then your formula is y equals ax squared plus bx plus c. Okay? And to find this, or the things you need to know, the pieces you have to be able to get this, is you need to have your a sub 0. You need to have something, which we'll talk about here in a second, and you need to have a second layer difference. I'm just going to say diff because I'm too lazy to write the whole thing out. Okay, so I need 3 things here. I need 1, 2, 3 things. We'll talk about that mystery one here in a second because that's the one that gets freaking everybody. So on this right here, what do you think you would just do right off the bat if I gave you a table? What?
Find the difference.
Find the difference, of course. Okay, so finding the differences, I got a 3 here, 4 going to 9 now,
5.
4 and 5, we got a 5, 9 going to 16.
7.
Ooh, we got a 7. Okay. So my first question you should think about is this linear?
No.
No, it's not linear, okay? So I do it again, and I do my differences of the differences, the second layer of differences, okay? First layer, I'm gonna say first layer, and I'm gonna draw an arrow, and this is my second layer, and I'm drawing a arrow, okay? So my second layer difference between 3 and 5, it's going by 2. 5 going to 7, oh my gosh. 2.
Whoa.
And I have found my consistent repeated number. That's what I'm looking for, okay? If this consistent number was here, it would be linear, and it'd be a first layer difference, and it'd be y equals x, whatever. Second layer difference is what this entire test is talking about. So, my second layer difference, for the sake of this problem, is a 2. It's right there. It's repeated. There you go. Now, what's the other thing that I need to find that you should know how to find? A sub 0, okay? So I need to find the a sub 0. I cannot use the second layer skipping over the first layer to affect this layer. I see a lot of people go back by 2 because they see the 2 and they go back by 2. Nope.
No, you gotta find the first layer.
Yes, so using the second layer, like a bunch of, like layers, I'm gonna use the second layer to go back 1 layer to use this 7 minus 2 is 5. 5 minus 2 is 3. 3 minus 2 is 1. And now this 1, I can now, in the original problem, x and y, I can now use the first layer to go back by 1 to be where?
0.
0. Very nice. Okay. Now, let me move this one to a better spot. It's right here now. Yeah, okay. My question, do you notice anything about this table, these numbers? I got 1, 1, 2, 4, 3, 9, and 4, 16. Notice you notice any relation they might have? By themselves. What's that called when you multiply a number by itself? Squaring, right? Yeah, like so 7 squared is 49, right? So if you notice these things are being squared, which is kind of weird. I did not know that this is how it works as far as squared numbers. But let's see what the 5th term would be. What should it be? Well, 5 squared. What? 47. 25. It should be 25 because 5 times 5 is 25, right? Let's see. So if I continue this pattern, 7, I continue the pattern by 2. So now this was 3, 5, 7. The next one would be 9. So 6 plus 9, oh my gosh, it's 25.
Whoa.
It works. And after the 9, I would keep going by 2, right? And after 9 would be 11. So 25 plus 11 is 36. Oh my gosh, that's 6 times 6, and it keeps working, right? It's kind of weird.
Is that the mystery thing?
Is what?
Is that the mystery thing?
That's kind of I learned that when I was like 25 years old. I was like, what? I didn't know that's how that works. That's crazy. So there you go. All right. Now, you've already identified the second layer difference. It's 2. And as you've noticed also, it continues to always be 2. Okay. What was a sub 0?
0.
0. Now, I don't want you to think that the a sub 0 will always be 0 because of zeros. And I want you to think the second layer difference will always be 2. It's not like that. It just happened to be this way. Just wanted to clarify. Now, the next thing and the mystery thing and the biggest thing for today, if I had a red marker, I'd be writing in the red marker right now, is first layer.
Ooh.
In fact, I'll call it the first difference. Okay, so I'll just put that difference back. Diff.
The first diff.
What is the first difference? So far today, nobody's gotten it without all the clues. One person's got it with the final clue. But what's the first difference? 5? Here,
Yeah,
5, is this 5?
No, it'd be the average because if you add them.
Ooh, interesting, average. We're going to talk about that too. Anybody else?
Or is it 2 because you're subtracting? No, yeah, you're going by 2s for the first.
2 because you're going by 2s?
Yeah, because that's the difference for the.
It is the second layer difference. But I'd say it's not the first layer difference, okay? So the biggest thing that pops up is averages. If you remember from Unit 1-4 and stuff from Unit 1, if you were given a series of numbers and they didn't work, average them. That's a great wrong thing that you're doing right now. I really, really like that y'all are doing that. That is good. But here's the problem. Remember when I first gave you all this table? When I first gave you the table, all I gave you was this, right? All I gave you was 3, 5, and 7, right? You found that and cool.
Yeah.
So if you average 3, 5, and 7, you would get some number, right? We don't have to do that. I don't really care what it is. But then as soon as I add in this 9 and this 11 and I extend it, now wouldn't that average change?
Yeah.
Yeah, so then now it's you never want to have math depend on how many things you wrote down, like the human writing the table. What if I keep writing it? Now it keeps changing and now it's very inconsistent. So I need to be able to have one reliable number that no matter what I choose to do or no matter how far I write it is always the same. But again, that is a very good thing that you're thinking about averages. So it's not going to be the average. Anybody else have a thought? So sorry, let me fill back in 1, 3, 5. Okay. Any other thoughts? Second layer, now here's my question. Why is it weird when I ask for the first layer difference? Second layer difference is obvious because it's just 2, 2, 2, 2, 2, 2, 2, 2. Why is the first layer difference weird right now?
It's not linear.
Well, it's not linear, and I think what y'all are meaning when you say not linear is it's not the same. It's not a repeated
Yeah, it's
number,
not
right?
consistent.
It's very obvious that this is the second layer difference of 2. It's almost hard to not be 2 because it's just 2, 2, 2, 2, 2. It's all 2s. So here's my final clue here, and this might help. I don't call it the first difference. For the first 2 years teaching this thing, I did call it the first difference, and it confused people just like y'all are now. I have from now on started calling it the first difference. And I'm not stuttering or repeating my first. It's the first difference. So what of these numbers would be the first difference?
3.
The 149.
Ooh, okay. So that pops up a lot. So the 1, 4, 9, 16, 25. Okay. Are these differences?
Oh no.
No, this is the actual table itself. That's the problem, right? The first row of differences is this. This is your first row. So I'll go ahead and label it here. This star right there, this is your first layer of differences, right? So it's going to be there, okay? So what's your first difference?
3, 5, 7. 3.
I heard 3, 3, 5, 7. Okay, I see that. Yeah.
1.
1. I see that too. Okay. So your first difference. And for the people that said 3, why'd you say 3? That's the first one. Yeah. So before I wrote anything down, right? That was the first one. But then again, that's what I'm kind of trying to get at. Why does it matter where I choose to start the table at? You know what I mean? Like I could have chosen to start the problem here, and I could have given you 3, 4, 5. You know what I'm saying? So then is the first difference now 7?
No.
See what I'm saying? So I don't want you getting stuck into, it's the first number that Coach B wrote down on the board, you know? Or like, I don't want you to think like that. The first difference is 1. Okay? Now there's a little bit more to that, and that might seem a little easy, and there's a curveball to that. So for the curveball, I'm gonna put a star right here, and we'll see if we can stick with it. And actually there's a star right there. Hey, perfect.
Hey.
That is the first difference. Okay, and I'm going to stop right there. I'm not going to keep continuing. until we do this one, and then we'll see if you truly understand what the first difference is. And there's gonna be a bunch of light bulbs, and you'll hear it here at home. And I might hear the person watching this video hear it say, "Oh," out loud as well. But it's gonna come after this one, so I'm holding you all up here. Okay, do it again. This is a more complicated one. Let's do it again. So what do we start off with? Differences. So here we go. I got 2.
4.
We're going by 4.
6.
And 6. Okay, easy. Oh, how easy. Thank you, Coach B. What's the second layer difference?
2.
2. Oh my God. So I'll write it again here. So my second layer is 2. All right. First, I'll hold off on that for a second. But what's my a sub 0?
7.
Ooh. Say that wrong answer again. 5. What made you say 5? Oh, it was the top. But is it 5?
No.
No. Why is it 7?
Because it's right next to the 0.
Because it's next to 0. So you see, and that's why I jumped on that. It's so huge. Did it matter that I chose to start the table at -1? Does that change a sub 0?
No.
Where Coach B decided to write this table? No. It's always connected to what?
0.
0, right? The 0. Okay. So yes, very nice. So a sub 0 is 7, not 5, not 11, but 7. Okay, cool. So now my question is, and this will really tell me if you know what the first difference is. What's the first difference?
4.
2.
2? 4? 4?
That's 4. Because because I feel like it has to involve with 0, and it's talking about the first layer.
What if it's like the absolute middle?
Ooh, the middle. The middle starts to get back towards an average, and I don't want us to think of an average because then I could include more numbers, and then that gets a little messy. So I like that it's between 2 and 4 right now. I like that it's between 2 and 4. That's probably happening now because we have the 0, right? The 0 is connected to the 7, right? Okay. Ooh, no. So your first difference is 4.
Yes.
Okay. Your first difference is 4. Now, the people that chose 2, what made you probably choose 2?
I was going to say 4 because I said 2, but the reason why I was going to say 4 is because I saw the 0 connected to 7.
Yes, and it's all connected to the 0. For the same reason that a sub 0 is 7 and that it's not 5 or it's not whatever number I start at, the biggest reason why people pick 2, and let me just try to get into your own heads, is it's the highest written number, right? And that's kind of what y'all are talking about over here. It's the highest written number. Oh, it was 3 because that's where the highest written. Nope. Doesn't matter where I choose to write the table. I just randomly chose to start it at -1. I could have chosen. In fact, let's do this real quick. Okay. What if I wanted to get -2? Let's go back. Okay. And this is important too. You're going to need to be able to do this on the test. So stay with me here. What would this be going back by? By 2. So 2, go back by 2 because you got to start with the second layer, then to the first layer, then to the, okay. So 2 minus 2,
0.
0. Cool. So 5 minus 0, 5. Okay, cool. So now, is the first layer now 0?
No.
See what I'm saying? No, it doesn't matter it is still 4, always. Now, I do want to do this one more time because something weird happens. Go back by 2 again. So now 0,
-2.
well,
Like
0
-2.
minus 2 is -2. This is going to catch people. Here we go. Uh-oh. What would be here?
3.
3? Is this on the camera still? It is, okay. Hey, what? Ooh.
Yeah.
Ooh, 7, -7, interesting. Okay, so it is 7. Okay, so watch this though. Right here, I have 7, right? And then I 7, 5. What did I do with this 2? I subtracted it, right? I see a positive 2 there. It's literally on the board. It's a positive 2. But where am I going?
It's going negative.
I'm going backwards, so I'm going to do the opposite thing, right? So 7, I see a positive 2, but I'm doing a -2 to get 5. And that works because 5 plus 2 is 7, right? Forwards and backwards. 5 minus 0, yeah, 5. I see a -2, but what am I thinking in my head when I'm going backwards? 5 plus 2 to get 7. Yes, okay, and then 7 minus 2 is 5, and it works going forwards, okay? So careful with that. That's something, just another little tip there. So anyway, as I'm trying to show, the first difference does not change no matter how far back I go or how far down I go, whatever. It's always chained between 0 and 1. It is between 0 and 1. It is this and this. That is the first of all the differences that happen. That's the first one, because 0 to 1 is the first interaction thing there, okay? That's huge. So it'd be 4. And then what we're gonna do later on or in the next video is I'm gonna take these numbers and we're gonna plug them into this, and that's how you find your equation, okay? Just like we did with y equals dx plus a sub 0, okay? There's that, okay? Also, let me throw this out there. As a bonus round, last test we had y equals dx plus a sub 0, okay? From now on, because y'all are all advanced enough, what's up, somebody?
Someone's at the door.
Oh. Gotcha. So from now on, whenever we're doing this thing, I'm going to write y equals ax plus b. Why do you think I'm doing that? Huh? Because this next unit is y equals ax squared plus bx plus c. Okay? What do you see? Do you see anything that's happening here?
There's a lot of steps.
You're just adding.
That's not necessarily a step. It's just this is linear, right? What is a? What is a? Y equals mx plus b.
Your slope.
Yeah, it's your slope. See how all three of these are the exact same thing? Rate of change, slope, difference, pattern, all that kind of stuff is all the same thing. A sub 0, the 0th term, y-intercept, all those are the same term, okay? I'm writing it like this from now on because ax plus b is the same thing as ax squared plus bx plus c. It's just added a c. And then in the last test, in the unit 3 test, is going to be y equals, let's see if y'all can catch on to it, ax cubed
Plus b.
plus bx squared plus cx
Square.
plus, we already did the squared.
Oh, plus d.
D. Oh, that is a month from now though. So
I don't like
a month and a half from now. So don't worry about that too much. If you notice, there's an A, B, C, D. There's a cubed, squared, X, and it keeps going down. This pattern repeats all the way into however big you want to go. But this is as big as we ever get. Okay. What a perfect time to end the video.
Good job.
Pacow.